finished. Okay, so you're going to tell me, yeah, it's nice. It's we have a network. We understand. But what's the purpose of this network? Why do we need to put together this network? Well, the very first reason we need to do that is to calculate the whole duration of the project. Okay, so how do we compute the duration of the whole project with a network like this? Well, that's going to be the second part of this presentation. Here we can see that we're going to introduce two orderly law squares, B and C. What are going to be B and C in my network in every cell? B is going to be the early start, that is when you start the task at the earliest. And C is going to be the early finish, when you finish the task at the earliest. We're going to see what it means right away. Okay. So here, what is the earliest start for A, B, and C? Well, it's 0 because they start at the very beginning. So we start, the stopwatch at 0, and they start at 0. Now, what is the early finish of A? Okay, well, A will last 6 days. That's a minimum. So the early finish is going to be 0 plus 6. I'm going to do addition here. It's going to be 6 days here. What about B? B, 0 plus 4, 4 days. That's the early finish of B. And as for C, 0 plus 10, it's 10 days. That's the early finish of C. So this is represented here by this. What I've just told you is just represented here. So if A finishes after 6 days at the early finish, what is the early start of D, knowing that it follows A? Well, it's 6. E follows A, it's 6 as well. Okay. Here we're going to take a look at that. Okay, 6 as I've told you. Now, F and G have two antecedents, okay, B and C. So before F can start, okay, B and C must be finished. You can see that B will finish after 4 days, that's the early finish, and C will finish after 10 days. So it means that F cannot start before the two tasks here are completed. And because C will last the longest, the duration of C will be when F can start. So you can see here when you have two tasks as antecedents that don't finish at the same time, the one finishing the latest will be the one that you select to start the next. It makes sense. In order for F to start, both B and C must be finished. And C finishing the last, well, F will have to start right after C is finished. Okay. So F will start on day 10. Same for G. G has two antecedents, B and C. You can see there are two arrows here. So G has to wait until C is finished. B will be finished way before, and it will start on day 10. Okay, and then I do exactly the same. 6 plus 3 is 9. 6 plus 33 is 39. 10 plus 20 is 30. 10 plus 19 is 29. Okay, and here I have what we call the early finishes of all my tasks. Okay, so I move on to tasks H, I, and J. Okay, so H will not start before the 9th day when D is finished. So 9 plus 15 is 24. It will finish at the earliest after 24 days since the beginning of the program. E and F, both of them will point toward I. So as I told you before, you must finish all the tasks coming before I so that I can start. So E finishing later than F, E will give its total duration to the beginning of I. So the early start of I, 39 plus 7, means early finish is 46. Okay, J has only 4 antecedent G, so it's pretty easy, 29 plus the duration, 50. And here I have when all the activities finish. H after 24 days since the beginning of the project, I after 46 days since the beginning of the project, and J after 50 days since the beginning of the program. So what is the finish date of the program? Well, that's given by J, that's plus 50 days. And that I will mention here in the finish. Okay. All right, so actually the finish is the duration is 0, so we can see the two values here are equal. So I've done the first thing I wanted to do. I've computed the total duration of my project. And without the PERT technique, that would have been impossible to do. So this is very, very important and very useful. So what is my next step? What am I supposed to do now? What do we do once we've computed the total duration of the project? Well, we are going to concentrate now on a very important concept, which is the concept of the margin. Okay, the margin, we briefly mentioned it yesterday. It's how much time do I have between tasks, okay, if I have any. Let's take a look at what the margin is. So as we saw yesterday, margin or float is either the difference between the earliest date, and you're going to read all this, okay? But what I want you to really understand is how it's computed, how we actually do it, how it works, okay? Total margin, that's the one we're going to concentrate on, is a maximum period by which the start of an activity can be delayed from its earliest start time without affecting project duration, okay? Basically, the question is, if I have an activity, can I delay it or not? By that, I mean, if I delay the activity, will it delay the total duration of my project or not, okay? So we see whether that activity is critical or not. If the activity cannot be delayed without delaying the entire project, it's called a critical activity. If it can be delayed, it's not critical. And a critical activity has zero margin. It means no freedom, no float. And we need now to compute what we call the total margin. Okay. So how do we do that? Well, it's going to come here. In order to compute my total margin, my float, I need to obtain what we call the late finish and the late start of the project. Okay, this is what we need to do. The late start and the late finish. So how do we compute such values? We're going to see that right now. Okay. So in order to obtain my all my values, what I'm going to do, I'm going to start by inputting here. I remember here, D is a late finish, E is a late start. Okay, so I'm going to start with a late start, and I'm going to obtain the late finish. Let's see how it works. What is the late finish, okay, of my activity? The late finish of activity H, that's the latest at which I can finish the activity. Remember, we said that the project will last 50 days, J finishing after 50 days. So the late finish of activity J exactly the same as its early finish, 50 days. But the project lasting 50 days, H was originally finishing after 24 days. Okay. Now, because the project lasts 50 days, it can finish on the 50th day if we want. Okay, it's no problem. So you can see the difference between when it actually finishes and when it can finish is 26 days. That's the margin. Same with I. I has to finish after 50 days. It's constrained by J here. It's here, the 50 days. But I was initially finishing after 46 days. So there is a difference of 4 days. And that's the margin, okay? I has 4 days of margin. As for J here, well, it has 0 days of margin, okay? So it's a critical path. It's on the critical path. It's a critical activity. And here, what I've obtained is, of course, the late finishes of every activities, then the margin being the subtraction of the late finish and the early finish of every activity. Some of them have margin, others don't have any. The margin is 0, okay? So that's